What's good, everyone? Welcome back to our live stream with Mr. Peters. Today I'm going to be going over the part 2 of the algebra review. We're going to look at about 5 or 6 different problems. And what's going to be so cool or so good about this video that I'm going to show you 2 different ways that we can solve the same problem. So let's say we look at problem number 1, right? They're asking us what is the range of the function. And this is another problem where we could just factor to find our answer. There's 2 ways that we could do this, right? And just understand that what we're looking at, or what we're looking for, is the vertex. We're looking for that y-coordinate so we could define the range of this quadratic. So the way we're going to do that is we're going to go ahead and try to figure out what is the x-coordinate for the vertex. And we could use the formula x is equal to the opposite of b divided by 2a. So when we look at the quadratic formula, right, ax plus by plus c, we know the first term is a. So x is equal to, first term is a, we have b, then c. So when we fill this in, we're going to have negative 2 divided by 2 times 1, and we're going to get x is equal to negative 1. Now what does this represent? This represents the x coordinate for the vertex. Now for us to figure out the y, we just need to now go in and plug that 1 in. So f of 1 is equal to 1 squared plus 2 times 1 minus 8. Now once I simplify, I'm going to get 1, and I forgot my negative. I'm going to get 1 minus 2 minus 8. So once I simplify f of 1, this is going to give me an answer of negative 9, right? So now I know that this coordinate, this vertex, is going to be negative 1, negative 9. And because it's opening up, right, let's say that this was that point, we should know that our range, the y, is going to be greater than or equal to negative 9. Now let's say we go back, right, and there's another way that we wanted to solve this. How could we solve this another way? And the other way I'm going to show you is by completing the square, okay? And don't worry, guys, we're going to make sure that this gets put up on our channel after the live stream. So we're going to complete the square, and when we complete the square, we got to remember this. B divided by 2 squared, right? Because that's how we perfect or find that perfect square trinomial. So right here we have x squared plus 2x minus 8 is equal to 0. So I set my equation equal to 0. I'm going to bring 8 over so I can try to figure out that perfect square trinomial. So x squared plus 2x plus that c term is going to give me negative 8. And just understand, whatever you add on this side to complete the square, we have to add on this side. Now we could go back to this right here. So for us to solve this correctly, we're going to take half of 2 and square it. All right, so that's just going to give us 1. So we're going to add 1 on both sides. Let's just put this before I mess my signs up. Moving too fast. All right. So now that we know this, right, let's break this down. What binomial is going to give us this? And typically, whatever we divided the middle term by, it's going to be that squared. So what do I mean? 2 divided by 2 gave us 1, right? So now we have x plus 1 squared is equal to 9. The square is now completed. This binomial is what will expand to get this perfect square trinomial. Now that that is done, we could bring this value back over, and what we'll have is x plus 1 squared minus 9 is equal to 0. So when we go over to a vertex form, let's just switch colors real quick so this sticks out. Vertex form, right? We're dealing with f of x is equal to a times x minus h squared plus k. This is the same format, basically. Only thing is that f of x, y, 0 is at the end. So what does that mean? hk from vertex form is going to give me my vertex. So when we look here, right, we have the negative 9, and after we take x plus 1 and set it equal to 0, we're going to get x is equal to negative 1. So we would have the same ordered pair or coordinate from that very first method we did, where we just figured out, we did a b over 2a and then plugged that in for y. So this is just another way we could also get the same exact answer. Just wanted to show you this. Now for our second problem, we're going to touch on an equation with a fraction real quick. All right, so problem number 2, this is what they give us. All right, let's write this out. And this is a multiple choice, so let's just write these answers out. Don't worry guys, I pick quicker problems, so I'm not going to waste too much time actually writing out the problem. All right, so the reason I really am excited about this video is because there's so much methods to solve different problems, and I want you to think of math as a puzzle, right? There's a whole bunch of ways to put the puzzle together. What works for me may not work for you, but I want to show you more than one way so you could pick what works best for you, or at least master one of them. So the first way we could solve this, right? Let's set up a proportion, right? So we cross multiply. 4 times 15 is 60, right? Yeah. 60 is equal to 3x plus 30, right? We subtract 30. 30 is equal to 3x. Now we divide. 10 is equal to 3. Right? Now let's say you were one of those students like me, you got on the test and you just got nervous, man. I don't know why you got nervous. So let me show you another way we could solve the same problem. And just so I don't confuse anyone, I'm just gonna clean off the board. Like I said, you could always re-watch this, we got you. So now let's say we have the same problem, right? And now, because Mr. Peters is a fraction expert, I said, oh, I know what to do. So let's say I multiply both sides of the equation by 15. On this side, that cancels out. I'm left with x plus 10. What I do on one side, I do to the other. I multiply by 15, divide by 3, this is 1, divide by 3, this is 5. 5 times 4 gives me 20. That's my new linear equation. Yeah, it's nice, right? I know. Now we subtract 10 from both sides, and we get 10 is equal to x. Which one is the right way? Whatever works best for you. To be real with you, I would have just did the proportion and solved it like that. I wouldn't even deal with the fractions. But some students are better with fractions. All right, so that's problem number 2. All right, and I really hope you guys have been enjoying this, trying to put these concepts together for you. So now what we're gonna do, right? I got a trick for you guys, and I really hope you like this. All right, so let's write this out, because this one is a little bit longer, guys. I am sorry. So they gave us a function, right? They say that the function is f of x is equal to 3x squared plus, and they want us to write this in vertex form. That is the question on what we're trying to do right there. But before we get there, let's just write out our answer choices, right? I want to make sure that we get this, because this is a really good problem that you're going to see. So the way that we're going to do this is by completing the square. And luckily, we just did a problem similar to that. But the reason I wanted to do this is because most of the time when we have completing the square, we do not have this lead coefficient. And let's just be real, it makes the problem a lot more complicated. But when we go into this problem right here, right, this is probably what we want to do. So we have 3x squared plus 12x plus 11 is equal to 0. So I always tell students, just set your equation equal to 0. Now we're going to bring 11 over by subtracting so that we could figure out what is this perfect square trinomial. So I have 3x squared plus 12x plus something is equal to negative 11. And at this step, what students always fail to realize is to take out the greatest common factor. So when I take out 3, we have x squared plus 4x, right? So now when we are completing the square, guys, just understand that we're focusing not on this step, but we're going to complete the square by what is inside these parentheses. So when I do b divided by 2 and then square it, this is how I'm going to complete my trinomial. So 4 divided by 2 is 2, 2 squared is 4. So the perfect square trinomial will be x squared plus 4x plus 4, right? I'm just writing it out first so you see it. What we're going to make sure that we do, we're not going to add it on this side yet. I'm going to let you know why. If you know why already, just drop it in the comment section for us. All right, so now we go back to creating the binomial that gives us this, right? So what was that binomial? X plus 2 to the second power, right? Whatever you divide b by and you get, that is going to be that number that's inside. So remember, 4 divided by 2 is 2. That is that binomial or that factor that's going to get us this perfect square trinomial. All right? Hold on, did I make a mistake here? Hold on, let's make sure. Make sure I didn't make no mistake, guys. I gotta make sure because I feel like I made a mistake. I'm moving too fast. Let's make sure. No, I'm good there. Oh no, I didn't make a mistake. Okay. So when we get here now, guys, this is the binomial we're gonna get, and what we're going to be adding, right? We have to make sure that we take our outside number and multiply it by c, right? Because once we expand it, we still have to multiply by this GCF, and that is the number that we're going to add on both sides, right? So this is how we get 12, right? So now that we're here, we break it down, right? We put it down to the binomial, and we simplify the left side. Negative 11 plus 12 gives me 1. Now from this step, we could go ahead and subtract 1, and my final answer should be what you see on my screen. Not on my screen, my board. And if we look, that answer is going to be C. Just remember 0, same thing as y, same thing as f of x when we're trying to solve. So when we're working with completing the square, and there was a leading term that is greater than 1, just make sure that you multiply it by c after you create your perfect square trinomial. Okay, that's something that I've seen lately, and I just wanted to touch on. All right, we got it. Okay. All right, so our next problem now, we're going to be dealing with functions and a little bit of function notation, but there's something that occurs in this problem that I want us to make sure that we understand. So they give us two functions, right? F of x is equal to, and they give us h of x. So they're asking us, they gave us two functions, f of x, h of x, and they're saying to us, what is the value of x when f of x is equal to h of x? So they're basically saying, hey, when we combine these two functions, right, or we set them equal to each other, what is our answer? That is all that they're saying. It is a multiple choice question, but I don't want to worry about that. What we're going to worry about is how to actually solve this, right? So let's switch back to black. So the first thing you want to do, like I said, is just to set these equal to each other. Right? So we're going to combine, but before we combine, let's just get rid of this fraction. So I multiply this side by 4. I'll have 4x squared minus 8x minus 32 is equal to, and then once we multiply by 4 on this side, we'll get x minus 4. Now we're going to go ahead and combine like terms. So we'll have 4x squared minus 9x plus, oops, not plus, I'm sorry, minus 28. So this is what we're focusing on now, factoring when there is a lead term that is greater than 1. So for the first method, I'm going to show you the slip and slide. You guys know I love this method. So we're going to multiply A and C together. Once I do, I get x squared minus 9x minus, let's just try to calculate it. I believe it's 116, but I can't remember off the top of my head. Is it 116 or 1? Let's see. 28. Is 112. See, I had to double check. All right, so you guys know that when we're factoring, we now want factors that multiply to 112, add to negative 9. So you know your teachers are always going to tell you, hey, draw them out, right? So we have 1 times 112, 2 times 56, let's see, 4 times 28, 7 times 16, and I believe 8 times 14. Now, this middle term lets us know, hey, with a certain positive and negative combination, we're going to get negative 9 when we add those two factors. The only two factors that are going to give us negative 9 are these two, right? So now I set this up. We have x minus 16 times x plus 7. Let's double check the notes. Yep, that is correct so far. All right, let's just make sure. And I'm going to erase this. So now with the slip and slide, you know how we took the 4? Oops, hold on. 4x squared minus 9x. The same way we took 4 and multiplied it by 28. After we now factor, we're going to do the same thing, but we're going to divide. So I divide by 4, this simplifies to x minus 4. It's my first factor. Second factor, when you cannot divide and get a whole number, you just take that denominator, put it in front of x. We have 4x plus 7. All right? So I'm not necessarily gonna focus on solving it like x minus 4 is equal to 0. No. What I want to do now is backtrack to the diamond method. I don't normally use the diamond method, but students have been requesting me to talk about it a little bit, and I want to do so in this video. So let's set back this diamond method up, right? Let's erase this. We got our factors. We know it should be x minus 4 and 4x plus 7. Let's just make sure we don't forget that, all right? All right, so let's set this up, and let's do the diamond method. Oh, man, always be forgetting about the diamond method. All right. Minus 28. Alright, so let's make sure. So, yep, that was right. This is interesting. Alright, so let's double check. All right, guys. So we're gonna skip that and come. I'm gonna come back to that because I think I misplaced that problem. All right, let's just skip that for now so I don't hold you up. All right, so let's go over to systems of equations. Yes, let's go to systems of equations. Can't believe I misplaced that. All right. So the first thing I'm going to show you guys is just the method of substitution. So anytime you have a variable by itself, you always just want to substitute, get it by itself. So let's say I solved for y. So if I solve for y, all I need to do is subtract x. So we'd have negative x plus 4. So what does this mean when we start solving this problem? This means that when I go into this first equation to solve, anywhere I see y, I plug this in. So here we go. We have 2x minus 5 times y. Remember, y is now this. So we'll put parentheses, negative x plus 4, close it, rewrite the rest of the equation. So now I have 2x plus 5x minus 20 is equal to 15. I simplify my like terms. 7x minus 20 is equal to 15. 7x is equal to 35. We know x is equal to 5. If I plug it back in, all right, let's just say we check real quick right here. 5 plus y is equal to 4. Y is equal to negative 1. So we know that x is 5, y is negative 1. So let's say that we didn't use the substitution method. That is also fine. What could we have also done? So let's say we just slide out here, right? And let's erase this so we could definitely see. So let's say we rewrote this and I multiplied this second equation by negative 2 so that I could eliminate my x. So first equation stays the same, right? 2x minus 5y is equal to 15. Second equation, everything gets multiplied by negative 2. So we have negative 2x, negative 2y, negative 8. X is gone. Negative 7y is equal to positive 7. Once we divide, we're going to get y is equal to negative 1. Right? So the same exact steps. I'm not going to plug it back into the other equation because we already know the answer. For x is going to be 5. But this is just a way for us to understand, not necessarily, this is a way for us to understand both methods, when to use them, how to use them, okay? All right. Let's go to the next one. All right, so the next problem, they gave us basically a sequence, and they want us to find a specific term. And we're going to be doing a lot more videos on arithmetic sequences and geometric sequences coming up in the later part of February. So let's be on the lookout for that. So let's say they gave us these two sequences, 1, 3, 5, 7. All right, that's number 1. And the second one is something like 30, 26, 22, and 18. All right, so the first thing we need to know is just the equation. So the equation for arithmetic sequences, right? We have, that was an ugly A. All right, we have A sub n is equal to A sub 1, make sure I'm just here, plus n minus 1 d. Now, I think the real reason why this topic is hard is because there's different versions of this equation. Another version you may see of the same equation is A sub n is equal to, make sure I write this right. And A sub 1. And I think depending on how your teacher teaches you, you could confuse yourself and think that these are two different equations, but they're really the same thing. They're just kind of one's written like basically backwards. So when we look here, the first thing we need to know, right, is this: what is the common difference between these numbers? right? They all should have the same common difference, whether it's 1, 2, 3, or 4. When we look here, we know the common difference is just 2, right? After we understand that now, they're just asking us, and they're asking us for the 24th term. Let's make sure we just circle that so we're on the same page. So now, when we go to fill this out, guys, all we have to do is to basically plug in, and this is what I mean. So when we go here, right, they're asking us for the 24th term, right? And let's say we did this equation first. So what is the first term in the sequence? 1. So we have 1 plus 24 minus 1 times the difference, which is just 2, right? Yep, there we go, there we go, there we go. Okay, right? So now once we simplify, we have a, so a to the 24, right? So 24 is equal to 1 plus 23 times 2. So now, once we simplify this even more, we're going to get a is equal to 46 plus 1, which will give us 47. If we use the second equation, it would be the same exact thing, and I'm going to show you guys that in this second sequence, basically. So first thing we need to do, right? We know the first term in the sequence. We also have to identify, is this a sequence? Is there a common difference between all of those numbers? And there is. The common difference is going to be equal to 4. So if now I'm asking you for the 24th term in the sequence, right? How would we set this up? So let's say we use the second equation, right? So we have the common difference of 4 times what? We know what n is, 24. We're looking for the 24th term minus 1 plus, what? What's the first term in the sequence? 30, right? Let me double check. Yep, we're good. And then, something that I always got to make sure that we touch on, right? Before I solve this. Remember that these numbers are decreasing. So unlike the common difference here of positive 2, just know that this will and can be negative, okay? So once I go ahead to now simplify, this is what we're gonna get. We're gonna get negative 4 times 23 plus 30. Let's take the calculator out. Sometimes I just be nervous, guys. That's all it is. I'll be nervous on camera. I know you guys think I'm supposed to be a veteran, but there's times that I do get a little nervous. Oh, okay. Yep, that's right. So we got 4 times 23, which is negative 92, plus 30. Once we combine these two, we should get negative 62, if I'm not mistaken. So this is how you would do arithmetic sequences, guys, and just finding a specific term in the sequence. Before we go, we're gonna go back to that diamond problem, because I really had something I had to tell you guys. So let's erase this. I'm gonna do this last problem, and then we're gonna call it a day for today's live stream. Thank you guys so much for joining us, man. All right, so let's see, where is this paper now? Alright, so I think I got it now. Alright, so let's write this problem back out, alright? Alright, so how did I do this? I can't. So we got these and everything.
Okay, I see what happened.
All right, guys, so what we're gonna do, I see what I did. I wrote the problem down wrong. So we're gonna end the live stream for today, but I'm definitely gonna bring this video back at the end of the week for you. Please make sure you join us on our next live stream 2 weeks from tomorrow. We always have a live stream on Wednesdays, but this week was Valentine's Day. Thank you guys so much for joining us today on our live stream with Algebra with Mr. Peters. Really hope you found this video helpful, and we hope to see you in the next 2 weeks at our next live stream. Thank you guys.